Greetings, I'm Kumar Parashari and I love doing physics. I'm here with problem number 7 asked in JEE Advanced 2020. It's very interesting. The potential energy given to be positive. If potential energy is positive, means the conservative force acting on the particle will be repulsive in nature. And if it is repulsive in nature, particle will not be able to follow up the circular path. When a charged particle, or for that matter, if a particle is following the circular path, the total energy got to be positive all the time. As I could see in these two options, the total energy is positive. This is totally ridiculous. I had to start the solution of the problem taking potential energy to be negative on the first side to make this problem practical. So the potential energy of the particle is equals to minus c times r. R is the distance where the particle is from the center, and I have preferred c over f. This is relation number 1. Now differentiate this with respect to r, du by dr, and this is equals to minus c, and by definition gradient of potential is negative times the conservative force equals to minus c, or Fc equals to c. Further, the conservative force need to provide the centripetal force for the circular motion to follow up. So let's write this to be equals to mv square by capital R equals to c. This force is constant, has great implications on this problem. The value of force is constant irrespective of the position of the particle from the center. I mean, the particle could be close to the center, particle could be far away from the center. The force, the conservative force acting on it got to be the same. And that is why I have written capital R in place of a small r, which you might have thought. This is relation number 2. And capital R, as I presume that you have read this question several times. So capital R happens to be the radius of the particle in the nth allowed orbit, and v is the velocity in the nth allowed orbit, and E happens to be the total energy of the particle in the nth allowed orbit. Now let's proceed. The particle, as per the problem, is in the nth allowed orbit. The radius happens to be capital R, and v is its velocity in the nth allowed orbit. Now, according to Bohr's model, the angular momentum of the particle in the nth allowed orbit should be given by nh by 2 pi. This is relation number 3. From here, v is equals to nh by 2 pi m into r. Substitute this value in relation number 2. Let's see that what do I get as m. This is nh by 2 pi m r whole square by r, and this is equals to constant, or m into n square h square upon 4 pi square m square r square, and this r I have written over here. This is equals to c. Further, if you see small m and small m will cancel, or n square h square equals to 4 pi square c m r cube, or r cube equals to h square by 4 pi square c m into n square, or r equals to h square by 4 pi square c into m raised to the power 1/3 and n raised to the power 2/3, and hence r is proportional to n raised to the power 2/3. So this happens to be the one of the option, if you could see that, and I'll check later. Further, if I substitute this value of r in this relation, let's see that what do I get as the velocity in the nth allowed orbit is given by nh by 2 pi m into r. Let's substitute value of r over here. Now as I substitute this value of r, so one thing about I should be very clear that let's substitute first. This is h square by 4 pi square cm raised to the power half and then n raised to the power 2/3. If we do not go into the further simplification part, then we should be very clear about the proportionality of V with respect to n. So V appears to be proportional to n raised to the power 1/3. Now let us check various options. So if I check options, then suppose V appears to be the correct choice. Furthermore, I need to check the total energies as well. Is that right? And let's see that, what really I could find out the total energy. The total energy got to be sum of kinetic energy plus the potential energy. And the value of kinetic energy, this is equals to half mv square, and the value of potential energy I have already chosen as minus C times capital R. Check, I have written capital R in place of small r. And from this relation, mv square by r equals to CR. I repeat, from here mv square is equals to CR. So I should be able to write that as CR, and this is minus CR, and this is further equals to minus half CR. This is the value of total energy. So total energy equals to minus C by 2 into R, and the value of R can be obtained from here. This is 1/3. This is h square by 4 pi square cm. This is h square by 4 pi square cm raised to the power 1/3 and n raised to the power 2/3. And this could be rewritten as, if you see, this minus c can go in, let minus half be out. This will be h square c cube, bring this n inside as well, so this will be n square whole 1/3, and this is upon 4 pi square c into m. 1c will cancel with 1c, square will be left, and this is equals to minus half h square c square n square by 4 pi square m raised to the power 1/3. So this should be the expression of total energy. So in my view, from the given 4 option, it is only the B option that matches, and C is incorrect, D is incorrect, and even A is incorrect. Thank you.